Hello all, good morning. We still wait for our head of department to join us and also our speaker to join us. So please be patient. Uh, they will soon join us.
Good morning, Mr. Dimas. Mr. Dimas from Sumardi. Mr. Dimas.
Okay, I would like to welcome Associate Professor Dr. Nazmi for joining us, but we still wait for our head of department to join us. Hello, Prof. Nazmi, could you unmute yourself? Hello.
Halo, Assalamualaikum Dr. Dimas.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
I am on the system now.
Okay. For the host and co-host, maybe the host and co-host can activate active speaker sharing for the screen. So I hope the host and co-host can manage it. Maybe we can start now, since our head of department have technical difficulties. So she will join us later. So we can start our event now, agenda now. So hello everyone. Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you for joining us. You are now with me. I am one of the lecturers in Department of Agricultural Engineering, Universitas of Brawijaya, and I will be your moderator for today's event. Today we will have the first international online guest lecture organized by Department of Agricultural Engineering, University of Brawijaya, Indonesia, in collaboration with University Putra Malaysia and SEARCA. Agricultural Engineering Department of University of Brawijaya regularly have an offline international guest lecture every year. However, due to the COVID COVID-19 pandemic situation, this year we changed the offline event into the online event. And usually we only provide the offline lecture to our students. However, this time with the online system, it is possible to have more participants. And we are glad and actually a little bit surprised to see the public interest to this event. We record almost 700 participants have been registered to this event from all over Indonesia and also international participants. We are glad to welcome all participants all over Indonesia and also from Malaysia, from Philippines, and also we also record here the registered participant from Japan and South Africa. I'm glad to welcome all of you to this event, and I hope this event will be useful for all of us. On today's event, I have already shared our agenda. However, it will be changed a little bit because our HOD will join us later. So we will start directly to the main event with Associate Professor Dr. Nazmi Nawi. And we will have the lecture for around 50 minutes. After that, we'll have question and answer. And I will give a chance to some participants to ask questions directly. And you can also write your questions via Zoom chat or YouTube chat, and I will read for the speaker. And before we start the lecture, I would like to shortly introduce our speaker. Dr. Nazmi Matnawi is an associate professor in Department of Biological and Agricultural Engineering, University Putra, Malaysia, and or UPM. He got his bachelor degree from UPM, and for his master and doctoral degree, he got it from University of Queensland, Australia. And he got a lot of experience especially in the field of machinery design and post-harvest technology. He has been written at least 36 peer-reviewed journals and present in a lot of conferences. He got a lot of awards, for example, Excellent Teaching Award from UPM, Best Presenter in Technological Conference, and recently he got awards of Serka Regional Professorial Chair. And today even also will be recognized as his Serka Professorial Chair. Okay, we don't want to wait. We don't want to make you wait anymore. Prof. Nazmi, time is yours.
Okay. Okay, thank you very much, Dr. Dimas. Hi, everyone. Very good morning. I hope you can see my face and my slide and listen to my voice, right? So thank you very much again. I would like to deliver my appreciation to Universitas Brawijaya for hosting this event. Thank you to all professors, lecturers in the department. And also special thanks to Head of Department, Associate Professor Dr. La Shovia. I was informed that she is not in the system yet. Never mind. We may talk to each other later. All right. So this presentation is about a series of or a requirement of Serka Regional Professorial Chair, which I just recently awarded with this award. So the title of this presentation is Agricultural Mechanization in Tropical Country, a case study in Malaysia. So my name is Nazmi Nawi. Currently, I am Associate Professor at the Department of Biological and Agricultural Engineering. Okay, so let's have a look what I have in this slide. So in this presentation, there are a few main components involved. First, I will take a short time to introduce UPM to all participants, and also about Serka. And then we talk about some principle on agricultural mechanization, and then a case study for oil palm and rice cultivation in Malaysia. Okay, let's have a look at this slide. This is about my university. University Putra Malaysia is a world leader in a new tropical agriculture. You can see a nice picture, and I hope I welcome all of you one day to come to visit us at UPM. Okay, at a glance, UPM is one of the premier public university in Malaysia, and it is ranked second second top university in Malaysia at the moment. And there are about 1,700 academic staff with PhD degrees. And we have 16 faculties, 140 degrees, and many more. Okay, so we are internationally recognized. We have received a lot of work, a lot of awards globally. Then I go quickly for this presentation, for this introduction. We have 16 faculties. We have a Faculty of Agriculture, which focus on agriculture science. And we also have Faculty of Engineering. With this faculty, we have Agriculture Engineering, where I belong to. Okay. So under the Faculty of Engineering, we have 8 departments, and Department of Biological and Agriculture Engineering is where I work for, and this department is similar to your department, I believe. Okay, so UPM is very active in the international engagement. We have a lot of MOU, MOA, and currently UPM and Universitas Malaysia still has an active MOU. Okay. If we look at our department, it was established in 1975, even before I haven't been born. A very old department, and currently we have a few professors, associate professors, and we offered a 4-year bachelor's degree in agriculture and system engineering, and a few fields of master's and PhD by research. So typically, we have 4 major research areas. One of them is mechanization and automation. This is where I belong to, okay? And a few others. All right, next, I would like to talk a little bit about CERCA. It's the Asian Regional Center for Graduate Study and Research in Agriculture. So just recently, just this year, I think last month, I was announced that I am one of the recipients for this CERCA Regional Professorial Chair. So I feel lucky for that. And Dr. Dimas for accepting me to deliver this in order to fulfill the requirement of this. All right, so I hope all of the participants today take advantage of the CERCA, because CERCA is a platform for global community, or for regional community, for us to work together to be to link to each other, because CERCA provides many scholarship, many grants, many platforms for us to share our knowledge, to share our expertise, and etc. For future students, there are a lot of scholarship available for you to apply, either for master's or PhD degree. So please make use, fully utilize of the presence of CERCA in our community. Okay, now I would like to talk about agriculture in Malaysia, right? So similar to Indonesia, similar to Thailand, in Malaysia, agriculture is one of the important economic sector. And this sector provides employment for 1.6 million people. Okay, and this sector contributed 8.2% of our GDP, which worth about USD 314 billion, a very, very big amount of money. And this sector is mainly contributed by oil palm and followed by others agricultural produce. So in our country, in my country, sorry, we have food crops and we have industrial crop. Food crop is about vegetables, fruit, tubers, grain. We have 2 main grains. We have paddy, we have sweet corn and field corn, which are dominantly grown by smallholders. And on another side, we have industrial crop, our commodity, like oil palm, rubber, tea, cocoa, and etc. So there are many issues similar to other countries, especially those in tropical region, something to do with weather, something to do with the size of country. Okay, but among them, there are 3 important factors that require mechanization. The first one is the aging farmers. labor shortage, and the young generation which refuse to join our farming activities. Small-scale production
Apa tuh katanya?
and limited technological application. So this is the land use of oil palm and paddy in our country, in my country, sorry. For oil palm, you look at the red circle. For the moment, for 2020, we have about 5 million hectares of land cultivated with oil palm. And for food, for security food, paddy is consumed about 368,000 hectares of land. Okay. So facts and figures, a comparison between rice and oil palm. Rice is our security crop. We have to maintain the rice production for our self-sufficiency level, where oil palm is a commodity. We export for money. It's a golden crop. So there are total acreage, average yield per ton. For currently, we have 3.8 tons per hectare, average, national average, which is low actually, because the government aims to reach up to 5 tons per hectare and even 8 tons per hectare. And that is the national aim under that mechanization program. Okay, so this is our SSL targets in 2020, which means by this year, we aim to have 100% self-sufficiency level achieved. But unfortunately, due to COVID-19, due to some circumstances, we still cannot reach that, but almost there, right? We are almost there. So how to reach that target? That is the question. For that, the government has introduced national agricultural policy. Under that policy, one of them are mechanization, automation and mechanization, appropriate mechanization and automation to be enhanced in our agricultural sector. So, what is the scenario now? Farmers in the world, this is a world fact that throughout the world, there are only 5% people who are doing farming. And from those 5%, most of them are elderly. So sooner or later, we need replacement for that. So this is important for us to modernize our agriculture sector through mechanization, automation, and digitalization. Because skill labor, agriculture decline, increasing aging factor, etc. So in Malaysia, we have 31.8 million population. 43% of them are youth, but only 50% of our youth involved.
Mama tutup aja pintunya.
So this is only due to 3 factors: difficulty, tragedy, fatigue. So we are slowly going to change this.
Tapi nggak beli ya, puter-puter kok.
Okay. So according to Mr. J, agricultural mechanization
Ingat, selalu sebelah kiri.
is not an option. We have. So,
ya, itu sudah.
According to National Academy of Engineering, when they characterize the significant achievement, the great achievement in the 20th century, agricultural mechanization comes at the rank 7 after electrification, etc. So, meaning to say that in the world, the technology is advanced, it's almost mature. But how that technology will be brought into our country? That is another question. The technology is there, but do the technology have come to our country? That's what we have to look at. Okay. So in general, what is the mechanization? Mechanization is a process of using tools, implement, and machine. I hope all of you distinguish the difference between tools, implement, and machine. It is used for agricultural land development, crop production, harvesting, and until processing. Mechanization can increase farm worker productivity when we measure in terms of field capacity, hectare per hour. Okay? Mechanization can increase farm productivity by maintaining the timeliness of operation between each machinery. For example, when combined harvester finish harvesting rice, the lorry is already there to wait for the harvested grain. So the combined harvester doesn't have to wait. They just unload, then keep going for harvesting. That is a time limit. And the good quality of work. Of course, machine can perform operation at uniform rate and uniform pattern. So mechanical power is about replacement of human and animal power, right? And then it's cover everything from manufacturing until distribution. Hand tool technology is a basic. For example, hand tool is like a hoe, is like a knife that our elder generation used to use that before machine comes in. So draught animal is not,
Monggo.
but it's still in some countries or even in Malaysia, in some parts, we still use buffalo for oil palm in pit area. So mechanical power technology is the highest level because we can have power at different levels.
Sebelah kiri ya, Raf. Selalu
Tractor may come at different horsepower. We can have 60 horsepower, 100 horsepower, depends on what we need. And
iya.
there are many.
Udah bisa, pokoknya harus selalu sebelah kiri.
We have
sorry for all participants, please mute.
Okay. And in my country now, there is a new trend where people are crazy about using drone for as a platform to go for plantation. Okay, there are many reasons for mechanization. The first one is to reduce the burden and drudgery of farm work because, for example, if previously when we want to plow the soil, we have to use a hoe, but now we just drive on tractor attached with a rotavator or this plow can just start the engine and move. Okay, it becomes easier. And then mechanization can increase the work output per worker. This is what we mean by field capacity. And then it will allow more effective and efficient usage of agriculture. It can minimize high peak labor demand during certain time. For example, during harvesting. Normally, during harvesting, we need many people because harvesting must be completed within certain time. If we go beyond that time, the crop, for example, the rice will fall down, will become losses. To improve the timeliness, I mentioned before, to encourage better management, to improve working condition, because farmers can now sit under the tractor with a proper cabin. Even some tractors, they have air conditioning system to keep the drivers comfortably. And to accelerate the process of transforming industry to be modern. And the last and not least, tractor can also be used as a platform for us to adopt precision agriculture and IR 4.0, Industrial Revolution 4.0, which is a very becoming main topic lately. But still, mechanization, if not used properly, they also offer some limitation. For example, it may offer redundancy, machinery for labor substitution, meaning that some people lose the job, but that is not for long time because new job will be created, right? And then when we talk about machine, they involve capital investment. We have to buy, we need to have money for that. But most of the places, even in Malaysia, government give incentives in terms of tax, grant to make farmers easy to own a tractor. And then handling a machine needs skills, needs a training, and then sometimes machinery doesn't live up to expectation, mainly due to overuse or underuse. For example, you overpowered or under power. The design, the tractor was designed for 60 horsepower, but you use them to carry the load more than 60 horsepower. So it will be overused. Healthy and safety, the last one is environmental cost. So there are many types of agriculture. We have tractors, which is very common. We have self-propelled machine. We have implements. Some implements require PTO. Some implement doesn't require PTO, and a combination of that. We have 2 wheels. We have 4 wheels. We have a tractor machine, which is a tractive work type. They need to be moved. They have to move on the field. And then some machine is stationary. It's a stationary machine, which like for dryer, for example. It's a machine, but it doesn't have to move in order to be operated. So there are two questions when we want to introduce new machine. We want to introduce new system for farmers. We have, they will ask us 2 questions normally. So 2 important questions to be answered before we introduce new machine is the field performance. Can our new machine, our new system beat or perform better than current system in terms of field performance? Number 2 is cost. Long term, to the machine, does the machine that we offer will be cheaper to run than the current method? So these 2 questions must be taken into account when we talk about machinery. So because machinery productivity, performance can be measured, there are many formulas like theoretical field capacity in terms of hectare per hour, effective field capacity, field efficiency, machine index. All those things can be measured because there is a formula. It comes to research. That means before we introduce a certain machine, it should be tested first. Either it is ideal or not to repeat our current method. And then number 2 is cost, because every machine, when it is operated, it comes with cost. Then it can be calculated. Total machinery cost can be calculated by by counting the ownership cost divided by annual usage plus operating cost. What are the components for ownership cost? Is a depreciation. It's a tax. Tax may be different from country to country. A shelter, insurance, interest, and then for operating costs, we need to take into account the fuel, lubricant, repair and maintenance, and also labor, either for driver or for assistant to help driver, right? So when we know all those components, it can be calculated, then we will know what is the total machinery cost for that particular machine per year or per month. So by having that number, by having that figures, it can be compared with current methods. So in order to adapt new technology, we have to transform, or we have to identify 3 things. And the first one is people. Who are going to operate the machine? Do they need training? Are they ready to change? Do they have awareness? Do they ready? Or because some people, they refuse. I heard the story that when a machine brought into the farm, the farmers put it on fire. Why? Because they say if the machine is operating, sooner or later they might lose a job. So you have to make sure the people, your worker, is ready to accept the machine. Number 2 is the process. Because I will show later that farm operation involves many tasks, many operations. So it can be upstream, midstream, downstream. It can be land preparation, harvesting. So we have to identify which operation or which individual tasks which need to be modernized, which need to be mechanized first. Unless you have big money, then you can modernize the whole system. That is another story. And then technology. Choose appropriate factor or implement or machine or technology, sensors or etc. Okay, so we buy something that suit our need. So normally in a crop production cycle, they will involve a few field operation. So I would like to ask, when you want to go for mechanization, ask yourself which operation, which task should be mechanized first, at least. So you see that on my left-hand side, we have harvesting. Crop selection normally happen at the nursery stage. Land preparation, after that seed selection, seed sowing, irrigation, meaning that there is a circle for crop production. And sometimes not all operations need to be mechanized. So it's not economic to mechanize them. So this is actually a basic operation involved in crop production. First, land clearing or land opening, or for oil palm, sometimes we call it
I'm sorry, there is technical difficulties for Professor Nazmi Nawi. Maybe because of the cloudy sky, so the internet connection is a little bit low. So we need to wait for some times until he could connect again. Please be patient. I will contact him. So while waiting for him, we remind you that we already shared the attendance form, so you can fill your attendance form, the attendance form, and later you can get a certificate that will be sent to your email. Okay, okay. Okay, I think.
Okay, sorry.
Okay, okay. Host, please change to Dr. Nazmi.
Okay. All right. Sorry. We work from home now, and then my internet is sometimes disturbed, especially during cloudy day. Now it's going to rain in my place. Okay. So let us continue. This is a typical field operation. We have cultivation, crop planting, crop maintenance, which includes weeding and watering. So each of the operation require different machine or at least different implement. Harvesting, for example. So we need to identify which operation critically need mechanization in order for us to introduce a new system. Okay, farm mechanization, in my presentation or my research interest focus on upstream level. Okay, downstream is different story because normally downstream is more established. They are done in a closed system in the manufacturing. Okay, but my focus is more on upstream in the farm. So there are two components for mechanization. The first is a prime mover and the implement. So prime mover is, in our context, is a tractor, and implement can be any implement to suit our operation. Prime mover supply power for various operations, and then a tractor or prime mover is developed to move load, carry implement, and most importantly, tractor can provide 4 types of power source. The first one is tobacco for pulling, PTO for operating implements, electricity. This is important for our IR 4.0. Electricity power is needed to run sensors, to run GPS, for example. So most of the modern tractors come with electricity socket. And then the fourth one is hydraulics. hydraulic is also one of source of power on tractor. This is typical powertrain. I think I don't want to explain about this. This is too technical, but just to let you know that if you are serious about mechanization, it is important for you to understand basic engineering. And when you talk about tractor, these three components must be in your brain. Drawbar pull is about ability of the power to pull implements. Tractive force is about how much power it has on the axle, on the wheels to make it move. And the rolling resistance is about interaction between tire and the soil. Okay? So four-wheel tractor comes with now different design, different horsepower, different capabilities. Again, you have or we have to choose the right one for our need. Don't buy too big tractor if our application is just a small one, because it will be overpower, then you will lose the money, right? That is the principle. Okay, when we want to understand the tractor, which is one of the component of mechanization, we have to be able to estimate power loss. Okay, as a agriculture engineer, we have that understanding, but I'm afraid friends from different field of engineering, they may not have this feeling. Okay, so because tractor mainly used for pulling the implement, so let's say the tractor comes with 90 horsepower or 100 horsepower. So never estimate that 100 horsepower is available at the drawbar power, because that the power will lose from the engine to the axle, from the engine to the drawbar pull, from the engine to PTO. There are mechanical losses, there are tractive losses, etc. So you look at the table, different undercarriage system, either two-wheel system or two-wheel drive, four-wheel drive or track, will have different efficiency or will experience different losses based on a soil surface, a soil type. If on concrete, it has better efficiency. If you operate your tractor on soft soil, for example, for paddy field, the horsepower that is available on pool may be half of the indicated power on the engine. So we have to know this in order to buy a proper size of tractor for our farm operation. So this research was done by Molari 2012. They use the same tractor, but they change the we call it undercarriage system, from the wheel to wheel with ballast to track with four-wheel track, etc. So they found that show a better tractive efficiency, which is main important characteristic for a tractor, especially a tractor which is operated on paddy field. They need to have a better or higher tractive efficiency. And the second thing is which can reduce soil compaction, because we know for paddy field it's a soft soil. Now when we go with heavy vehicle, it will compact the soil. It may break, it may damage the hard pan, right? So this is the consideration, but this is introduction, PTO. I believe those who are doing agriculture engineering know about this. So we just through a type of implement. Be careful that different implement comes with different draft resistance, with draft to be operated. So draft is the force required to pull the implement in the field. So if you fail to calculate the draft and you mistakenly attach the draft to the wrong size of tractor, it will damage the tractor. Okay, so if you use more than one implement at one time, it will be total draft. This is the accumulation of the draft. And then in agriculture engineering, mostly the draft for certain implement on a certain soil type is already provided. Okay, for your information, in agriculture engineering for mechanics and soil mechanics, we have three main type of soil, only three. First is clay. The second one is loam. The third one is sand. So that comes under light soil, medium soil, and heavy soil. So when we know the draft is needed to put an implement, so we can calculate what is the horsepower required on the tractor. Okay. Okay, this is the, okay, let's say you have a new implement. There is no data from the table. Don't worry, because it can be calculated. There is a formula, mean draft for every single implement. But again, because draft is about is created due to the interaction between implement and the soil, you need to know the soil texture or the soil classification. So in this slide, I show you that there are three types. You just ignore the silt. Silt is not a soil. So we have clay, which is for fine type, loam for medium, and sand for coarse type soil. Right. So this data is provided by ASABE, American Society of Agriculture. They have done a proper study. Unfortunately, for Asian country, especially for Malaysia, we don't have this library data yet. So we are yet to establish this data for our own, for localized data. Okay, but there is a way to calculate the draft so that you have a proper matching between implement and tractor. So proper matching is important because if implement are too large to the horsepower available on the tractor, it will cause overloading. So when overloading happens, the excessive tire slippage, you will consume more fuel, a higher incidence of tractor breakdowns, and unsatisfactory performance. So your machine may get damaged before it reaches physical time or economical lifetime. And then if the implement are too small as compared to the horsepower of the tractor, it will result in inefficient operation, low production, and increased cost, and may encourage the operator to use ground speed too high for either good machine performance or safety. So really, proper matching between implement and tractor is about money. It's about economic of the farm operation. Another thing is cone index, because if you remember, the formula for traction is P H minus R, and R is about rolling resistance, and rolling resistance is affected by soil surface or terrain. We call it terrain. So in agriculture engineering, we really concerned about cone index, the cone index value of the soil, because that will determine how big, how heavy a tractor can be used on that area. If not, there is high chance the tractor will we call it sinkage, will got bugged, cannot be operated. Okay, in principle, the upper condition of rolling resistance, either hard wheel rolling on hard surface, which have a very minimum rolling resistance. Second condition, hard wheel or high pressure tire and rolling on soft surface, and then soft wheel on hard surface, and then the fourth one is soft wheel on rolling on soft surface. So if we talk about paddy field, the soft wheel rolling on soft surface, that is the condition. So there are some formulas involved how to calculate rolling resistance. Okay. All right. So come to case study in oil palm. In oil palm estate, the harvesting operation required the most number of workers. So in our committee, we decided that if we want to introduce a machine under limited budget, we should prioritize harvesting, right? Harvesting operation consists of cutting activity, the cut with front, and then cut with FFB, evacuate the FFB, and then the cleaning activity, also collecting the loose fruit around the tree. The harvesting of FB from tall palm is currently not mechanized as the cost of such technology is expensive. Okay, so this graph shows that in all tasks or job involved in the oil palm industry, harvesting or harvester the number of harvester is the highest. That means if you have budget, you have talent, you have idea, you should focus on solving the harvesting problem. This as your priority. Okay, but again, because oil palm in Malaysia has been for 100 years and over, so machinery for this industry is almost established. Because you see, for example, for land clearing, we have for drain. The second photo is about drain development. We already have an excavator, and then this is loose fruit collector. It's a manual one, and for harvesting short palm, not tall palm, not tall palm tree, is already okay. We already have chantas. We have chantas sickle type. We have chantas a chisel type. But for tall tree, because you know the maximum palm tree can reach up 20 meters, and then imagine how we can have a pool to harvest from that height. Okay, and then a few more machinery which was developed, designed, but still is about acceptance. Some machine is applied, is used by plantation, but some machine is not really utilized due to ignorance of the workers and the budget for maintenance and etc. Okay, and then this is what we do at our department. At my department, this is what the faculty, the faculty members at our department contribute in terms of machine development. So this machine is a mechanized for planting, seedling planting, developed by Professor Nazmi here in my department. It's a single chassis machine capable of preparing planting hole, placing the seed, and then after that, it can compact the soil back before leaving. And then the same person, Professor Nazmi, also developed mechanized circle spraying of mature earth palm using forward drive prime mover. So don't confuse. Prime mover is just another name for a tractor. It's a farm tractor with front mounted sprayer unit. This is what we have done at the department. And a variable rate technology. This is to support precision agriculture, because we know throughout the farm, throughout the field, there is a variation in terms of nutrient availability, water availability, the health of the crop, etc. So under the precision agriculture, we only supply nutrient to only for the tree units. Tree who are already healthy, they may need little or less fertilizer as compared to unhealthy tree. So variable rate technology will be able to do that. So this is a potential for saving in terms of chemical application. Another design machine was designed is infill on palm fresh fruit bunch picker, because we know that FFB is very heavy. It's about 30 to 50 kilogram per bunch. If any of you have experience in the farm, you know how heavy it is and difficult to carry by hand because it has a tone. It's a thorny surface. This machine will make it possible. It may increase field capacity of FFB collection. Okay, another solution proposed by this faculty, this department, in order for us to harvest FFB at the tall tree. So instead of using pole, we can use this climber, self-propelled rotary cutter, where this machine can climb the tree, the trunk, and then cut the FFB, and then this robot can move from one tree to another tree. We have another platform for that. So this is an invention that we do at the department. And then a camera vision system for fresh fruit bunches, helping harvesting machine, and oil palm harvester machine has been developed. It's a joint effort with NPOB. NPOB is a research activity for oil palm. It's a Malaysia palm oil board with UPM. So we attach with CCD to to capture the picture and to decide whether the crop is matured or still unripe. Okay. The latest technology is using robot exoskeleton that can delay fatigue during manual harvesting. So this is under at the research stage. We hope that the positive outcome will come from this project. UAV is another platform similar to tractor. It's a platform to carry technologies for, in this case, is for aerial imagery to capture the image of plantation from air, easy to say. Okay. Okay. Now case study in rice. We have done significant research as well in paddy. So rice is one of the important. Malaysia is a staple food. In this industry, two things are critical: tillage and harvesting. Okay, tillage and harvesting are labor intensive and also energy demanding operation. So Malaysia faced a labor shortage, as I said before, because most of the farmers are getting older, and then the younger generation take over. Okay. Therefore, a combined harvester has now been introduced to mechanize rice harvesting, and it is done by contractors. There is no farmers who have their own harvester. It is costly to buy, but we use contract farming. I mean, contractors to harvest. However, traditionally, they use large and heavy combined harvester in paddy field, which we believe would damage or break the hard pan. Okay, a research was done by Mauzu to identify in the paddy crop cycle which operation is critically need to be mechanized. So from this study, he found that harvesting and tillage are two most critical operation which we have to intervene with mechanization technology. So at the department, we built a few machines. This is for rice seeding machine to support a system of rice intensification. I will flip through because I think the time is almost over. We also compared the performance of spraying between UAV technology. This UAV can bring payload up to 10 kilograms. So we tried to use this for chemical spraying. It seems to be okay, but the battery, we have to find a solution for battery because the battery needs to be changed very often. We come up with precision agriculture technology where we can produce a yield monitoring system using IoT, using sensors. And then we also conducted a study to compare field performance between half track and rubber wheel, because we know traditionally tractors come with rubber wheel, but nowadays many studies shows that half track or full track would be better, would have offer better tractive efficiency. So we conducted the study to compare the performance between wheel tractor and half track tractor. We also in the process of comparing the performance, including grain losses between traditional large harvester to a small, mini combined harvester. Okay, because okay, this is currently we compare the performance of 3 combined harvesters under the similar field condition. So you see that different combines come with different specification, right? And then another faculty members develop a sensor to detect or to produce a map for soil nutrient to study soil nutrient variability across the field. Okay, so conclusion: agricultural mechanization will offer a solution for labor shortage, but with condition we are able to attract younger generation to come into the industry. And secondly, proper mechanization could increase crop productivity by improving farm efficiency. Proper mechanization here means we have to choose the right size, the right type, the right matching between implement and the prime mover. And the third one is the understanding of principle of agriculture machinery will help us to fully embrace this technology. We have to understand about the soil surface. We have to understand the losses factor and etc. In order to optimize the application of the technology. And then research and development in this field is in specific locality, because we know soil between one area to another area is different. That's why we have a variability. Okay, so it is important to localize our research. It's a step successful for successful mechanization plan. Okay, so this is me in the farm. I used to work in the farm. I did my practical training there. So this is my last slide. If you have any question, you may ask, or you have any comment. With that, I thank all of you for listening, and I pass this session back to Dr. Dimas. Thank you very much.
Thank you very much for Professor Nazmi to delivering the excellent lecture. I will give a chance for any of you who would like to give a question directly. Please raise your hand, and I will mute you, and I will unmute you. And you can ask directly. Is there anyone who want to from Zoom who want to ask the question directly? Please raise your hand. So while waiting for participant who want to ask directly, I will read the question from Zoom chat. First is from Mrs. Huriatul Fitria. She is from Department of Computer Science, University of Brawijaya. Greeting Professor Nazmi. We know that machinery is the future of agriculture, but not many implementation we have seen nowadays, especially in developing countries. What is the main challenge actually to implement the agricultural mechanization? That is the first question. Maybe you can direct.
Thanks for the question. As I said earlier, that technology in mechanization is there. In US, they are able to produce the crop not just for local consumption, but it can be exported. Why? Because they fully utilize the machine. But again, there is developed countries, the story in developed countries, where they can, because they have a volume, when they come up with new machine, new product, they have a volume. But back to developing countries, the issues is we have small scale land area which is not suitable to use big machine invented or designed, developed by Western country, for example. But we have, and of course, it comes to cost. When we talk about machine developed or produced by Western country, it is expensive. We know that they have John Deere, they have previously massification, but bear in your mind that we also have producers in Asian countries. We have Kubota, we have Yamaha. Again, they also have established technology. Sometimes it's about mindset. Sometimes it's about our perception. And then look at my country, because farmers used to use machine from Western country. Yeah? They still, if you look at my slide, they still use massification tractor. But when I was in the field, the owner said the body is messy, but the engine is not messy anymore. Right? They change it themselves. So again, some technologies is expensive, but we can look for similar technology, alternative technology from another country. And then I got one question before. Why we don't, for Malaysia, for example, why we don't produce machinery? Actually, in Malaysia, we have a manufacturer for implement. Successful, we export to Indonesia, to Sri Lanka. But when it comes to machine, we don't produce because we don't have a volume to sell. We don't have volume to sell. So there is no market, no technology. So for the prime mover, we import, but for the implement, that is a developing industry. I used to do my training in one of the. So that's my comment. Thank you.
Okay, thank you very much. So there is one participant who raised the hand. So I will let Mr. Agustami Sitorus to ask the question directly.
Thank you.
Okay, thank you. Please introduce yourself first.
Okay. Very interesting presentation, Prof. Let me introduce myself. I'm from Indonesian Institute of Science. I'm Agustami Sitorus. Before I'm agriculture mechanization in master degree. I have some equation before. In your opinion, which are the part hot topic in the study from a tractor features, especially in the hand tractor, not for wheel tractor? Because in Indonesia, hand tractor is more popular between the four hand tractor. And second question, can you describe how deep the extensive your research in the UPM about the hand tractor too? And the three question is, in your opinion, how about the topic terra mechanics in your study in the prime mover or another about tractor? I think it's enough. Thank you.
Can you please repeat the first question, please? First question.
What?
Can you repeat the first question? Repeat the first question. I didn't get it.
Oh,
please repeat the first question.
Yeah. About your opinion about hot topic in the research in the hand tractor. You explained four-wheel tractor, but in my country, Indonesia, is hand tractor is more popular, more than the four-hand tractor.
Okay,
Can you see?
Mr. Agustami, right.
Yes.
First, I have to admit that at UPM in Malaysia, the use of hand tractor is not very popular because when we talk about paddy, they have 8 granary areas for paddy. So like is one big place, and farmers easily get a service from contractors. But farmers who do not have an access to contractors, or farmers who have a small land size from their parents maybe, and then the contractor refused to go there, so they will use hand tractor, or some of them use walking tractor, or we call it a power tiller, for another crop, not for paddy. Let's say if they are growing sweet corn, they are growing vegetables in a remote area where contractor that doesn't want to go, so they will. But it doesn't come to our interest to do research, because that is, represent a small portion of the community. But we used to do research on power tiller when we put remote control. We install a remote control on power tiller, so farmers like operating remote control car. They can sit under the tree, they just control. But again, the use of power tiller for paddy or for oil palm is not common. But power tiller or hand tractor is only used by a small portion of farmers for another crops, not for main crops, and in a remote area. Okay, but if there is an issue, well, we can do the research, because still the fundamental is the same, right? The second question is, I think the same question. The second question is also about hand tractor again. If there is a need, then we can do the research. But again, because a majority of the farmers in Malaysia, they get service from contractor who use either two-wheel drive or four-wheel drive tractor. Okay. The last question is about terra mechanics. We are serious in that research actually. If you come to UPM, we have soil bin facilities. We have a test rig facilities. We, in fact, I teach one subject, off-road vehicle engineering, where we really we are dealing with terra mechanics. It's about terrain, it's how the tractive efficiency and etc. So yeah, we have a research facilities, we have a research capacity in terra mechanics at UPM because we still have soil rig, soil test rig we call it, and also soil bin. Okay, thank you.
Thank you for explaining.
Thank you very much for Mr. Agustami Sitorus from Indonesia Institute of Science. And we have more questions from Zoom chat. So the second question from Miss Salsabila from Indonesia. Greetings, Prof. As we know, oil palm plantation is a long-term plan. So every time we harvest the plant, we have to make sure that we make the best out of it. But what are the common struggles when harvesting or producing oil palm plantation? About the harvesting.
Can you repeat the question?
Okay. So palm plantation is a long-term plan. So
Okay.
every time we harvest the plant, we have to make sure that the plant is in the best condition, or the palm is in the best condition. Also, what is the struggle in deciding the harvesting time? I think the question is like that.
Okay, thank you very much. In Malaysia, typically what we do, yes, oil palm takes about 25 years for replanting because after 25 years, the tree will be very tall and it is not technically feasible for us to harvest anymore. But some research suggested that the older the tree, the better the oil content of the fruitlet. But again, when it's dropped from high level, reach the soil, it will like split. Yeah? It will it may create more loose fruit on the soil, on the ground. Okay. This is about detecting the maturity. What we do now, what the estate does, they go by rotation. Okay. Normally they will harvest twice per month, but nowadays we have technology. We have a camera. Some of estate they use UAV to detect maturity, and then some company they have even apps at the smartphone. They have apps when they take picture based on the color of the fruitlet. They may determine when it is suitable for harvesting. That is the technology is available. And then the latest one, they build a machine, and then they detect the maturity by a camera, and if the FIB is ready for harvest, the camera will tell us, then the machine will cut it straight away. But that is at the research stage. Traditionally, they go by numbers of days. They go by number of days. Typically, if I'm not mistaken, they will harvest in every plot twice a month. But there is a technology to detect.
Yes, I think there is a gap between the research in university and the implementation in the industry. In the university we always try to do the research like cutting edge research using machine vision and etc. But sometimes the industry hesitate to implement the technology that we have been developed, right? Like that.
In Malaysia, it's like this because we have many companies. We have Felda, we have Chandabi, we have like United Malacca. Some research, if that company do the research, they may adopt that because even UPM, we always do research joint research. Sometimes we got funding from them, but again, in terms of application, every estate will have their own decision. If company A use this technology, doesn't mean company B will use. That is the trend, because maybe cost of factor, cost of labor availability. Some company refuse to invest in technology. Some company they look forward. Sometimes depends on the boss, the managing director. That's my comment. Thank you.
Yes. Okay, thank you very much for the answer. So we have one more participant raise the hand. So I will let Miss Putria Rompas to ask the question directly. You can unmute your microphone. Hello, Miss Putria. Please introduce yourself.
Hello.
And you can
Okay,
ask the
thank you for
question.
this opportunity. Yes. Thank you for the opportunity. My name is Putria Rompas. I'm a student from Agricultural Engineering, Samratulangi University. And as we know that full mechanization, especially for on-farming, are required nowadays. And here's my question, that is, what is the factors that we would analyze before we designing a machine so that it will work productively for that area? That's all my question. Thank you.
Okay. So if I'm not mistaken, the question was the criteria for deciding a suitable machine, right?
Yeah, and also the factors that we should analyze before designing some machine. That's all.
Yeah. Okay. Thank you. So yes, we have to choose the right type of tractors and the right type of implement in terms of cost, in terms of size, in terms of horsepower, and in extension to that, we also need to consider the brand, the cost of spare part, and then the easiness of operation. Because some tractor they have different design, and then some tractor it was designed for horticulture industry, it may not be suitable for oil palm. Okay, you have to consider, is it two-wheel drive or four-wheel drive? So at UPM, in my department, we teach this under a farm mechanization subject. So the analyst first need to consider the functionality of the machine. Either the secondly is about the size. Let's say for paddy field or in oil palm industry, if you want to decide the tractor, you have to choose the size of the tractor which can do the highest operation in your crop production. For example, you need a tractor to do first tillage, which require, say for example, 60 horsepower. You also need the tractor to run rotavator, which require only 40 horsepower. So you have to consider the losses, the soil type. So don't buy a tractor that can accommodate 40 horsepower, but go for the tractor that can accommodate your maximum horsepower requirement. Okay, that is the technicality. And then goes for the economy. Look at the machine that has, you can easily get the spare part. You can have people who can fix it, because some model, I experienced that in one mill, one machine just left on the shed. When I asked why, they said no spare part. Why? I said why no spare part? Because when you buy, because there is no authorized dealer, they buy direct from overseas, so there is no foreman or mechanics who can fix it. Okay, so that is a consideration. But first of all, you have to see the requirement in terms of power. What is the maximum power required to run your field operation? For paddy field, the most highest requirement is for plowing the soil. That is my response. Okay, thank you.
Okay, thank you very much for the answer, Prof. Nazmi. We have one question from YouTube streaming from Lenny Saulia from IPB. She asked like this: I think socio-engineering factor is one of the biggest difficulty in mechanization application. Could you please inform us whether there is any steps your government took to solving the case related with the socio-engineering factor?
Okay, thank you. Social engineering factor. I mentioned before there are three factors which we have to take into account to see the success of the adoption of mechanization. The first factor is people, the people. So people here, let's say, the problem is our elderly or oldest generation. They are not, I'm sorry to say that they are not well educated and they are refused to embrace the new technology. Okay, if you see parents or you see elderly or elder farmers, you say, Uncle, why don't you try this technology? He said, no, I still can survive with the previous method. So with the younger generation, what we do is first we create awareness. We say we told them, even I told my student that agriculture, if you do at the right size, farm size, you can be rich. You can be rich. There is opportunity. And then we have to create awareness. There is no longer 3Ds in our agriculture. Why? Because every manual operation can be done by machine, either by self-propelled machine or by implement or by a semi-powered machine. Okay. And then in terms of education, in Malaysia, we have the government has established more polytechnics. I'm not sure what is that standard in Indonesia, but we call it polytechnic for diploma level. They were trained to be mechanics. They were trained to be mechanization, people for mechanization. They can fix machine, they can be a supervisor at the farm. And then the government create incentive, easy loan for young entrepreneur in the agriculture. We also create a grant for those who like to do agriculture. And nowadays we promote to modernize agriculture using sensors, technologies in line with industrial revolution. Where even power tiller or tractor, maybe in 10 years time, we don't have to drive it on the farm, but we can stay at home and everything can be done remotely with the IoT and etc. So yeah, the challenge is to create to attract the younger generation by giving them awareness, giving them to see the potential in agriculture. But yeah, there is the potential. So first you have to change their thinking, their paradigm. Create awareness, show them potential, make it easy for them to have an access to financial assistance for the technologies, and create a mentors. Successful farmers can be role model for them. So yeah, by time it will be successful. Yeah.
Okay, thank you for the answer. Yes, in some developed country, they already maybe said that they will implement agricultural 4.0 or even 5.0. Like you say that we can automate the tractor and etc. But maybe for developing country, still we are still ongoing. We have more questions from the Zoom chat. The third question from the Zoom chat from Miss Farida Kurniasari. She asked about, as we know that agriculture mechanization has several benefits, including increasing work efficiency. But related to the application in Indonesia, Indonesia has a lot land that's relatively narrow, and it is used for small-scale consumption. So the use of the tool still has less effective if used in some land of Indonesia. So it is related with the size of the machinery. In some area we have, like, if you know terracing, it is like in mountainous area.
Yeah.
We try to make the narrow space
Yeah.
for the paddy field. So how do you think about this situation? Is there any research or company that provides solution for this kind of problem?
So it's a matter of fact that any technology will have a limitation, and the same thing goes to farm mechanization. First, like for example, in my country, when we talk about oil palm, we can easily use tractor, but when it comes to pit soil area, we cannot use typical type tractor, but we have to use a tractor with rubber track. In some places, we still have to depend on buffalo for specific area. Then the second thing is the terrain. Terrain will be a limiting factor as well, because our tractor can only climb up hilly area with, if not mistaken, up to 40% gradient. If more than that, it would be risky for the tractor to overturn. Okay. In Malaysia, rule of thumb, if we want to invest in machine, the land size should be 2 hectares minimum. If not, it is not justificable to invest in machine. You better hire contractor. So, yeah, in order to invest in machine, the land size should be considered. And then for limited area, no choice, you cannot use big machine. You may have to rely on power tiller, or we call it working machine, if that is the only choice you have. But still, if you use power tiller, it's still better than you use manual hoe for manual tilling. So that is my response. So again, mechanization got limitation, especially when dealing with terrain, dealing with soil type, and then accessibility. So you just have to buy a bigger land.
Yes, thank you. Related with this question, we have also a question from Dr. Ari Ahmad from our department. Does your country, have a map for the feasibility of the size of the tractor by type of land? Any data on, any mapping on this, about the feasibility of the size of the tractor by type of land?
Size.
So
Size.
mapping about the feasibility of the size of the tractors.
Okay, what do you mean by size? Is it the horsepower or what? What do you mean the size? The width of the tractor?
Dr. Ari, maybe you can respond directly.
About ukuran ya, power of power with feasibility land. Nah, jadi ukuran apa? Ukuran power traktor dengan keadaan lahan. Ada tanahnya liat, tanahnya berpasir.
Type of the soil, and also the size of the tractor. Is there any mapping of kind of data?
Thanks, Prof, for the questions. As far as I'm aware, because still until now, when I teach that subject, I still use data from US. We still use Asabe data as a reference for matching between horsepower with soil type. As I said in the slide before, that there are 3 soil types involved in mechanics: clay, loam, and sand. So I have a plan actually before to build a library, a data set, a data library for that, but haven't got a chance to build that. But as far as I know, we don't have that, as far as I know. But I do not know if it was done before, previously, but still in my class, I still use reference from Asabe for teaching purposes. But there is an awareness, we need to have that, but in my understanding, we don't have that yet in my country. Yeah, thank you.
Okay, thank you very much. Also for Dr. Ari, thank you very much for the question.
Thank you. Thank
And
you.
we also have more question from Zoom chat. Hi, this is from Agung Cahyono. He is a doctoral degree student in Malaysia, from Indonesia. Hi, Prof. Nazmi. Based on your presentation, if I am not mistaken, one of the big challenges in developing and implementing agricultural machinery is about financial issue. How far the government policies, particularly in Malaysia, are able to deal with this?
Financial issues come into stages. The first one in the development, which is given in terms of research grant. The secondly is the extension, how our extension agency promote the technology to farmers. And the third one is how farmers or growers may own the technology. So up to the development, we at the university and research agency like MPOB, or for paddy, we have MADA, we have Department of Agriculture, we have MARDI, Malaysian Agriculture Research and Development Institution. The allocation is there, always the allocation is there, but it is competitive. So in order to beat the grant, we have to have a very good proposal, justificable, and it has to satisfy the requirement by the government. But the financial is there. There is one university, even research agency still survive because there's just a matter of luck. If we submit 10 proposals or if we submit 3 proposals, one might be approved. So there is condition. And then up to the extension agency, they have money every budget. In every budget, this government agency like Department of Agriculture, they have an allocation to buy a new machine suggested by the research agency, and then they will give that or rent that machine to farmers. So if you see in Malaysia, many new machine is reachable by farmers, but they are not individual farmers. They belong to the, we call it society, society that register with Department of Agriculture. And then for farmers, they can also get grant from government. I know one of my friends, he is running sweet field corn industry. They can apply for the grant. They can apply for easy loan. Even in Malaysia, we have bank. We call it Bank of Agriculture. So at a lower interest rate, any new entrepreneur in agriculture can get a loan from that bank. Now we call it Agro Bank. So yeah, financial is there. It is competitive, but if you do your best, your proposal is meet the standard, you may get it.
Okay, thank you very much. So for our students, if you not confident with your English, you can also ask in Bahasa Indonesia. I think Prof. Nazmi can understand, and also I can translate it for
even
Prof.
Arabic.
If okay, so don't hesitate to ask question. So we have question number 6 from Miss Arini from Agriculture Engineering Study Program of our university. As we know, one of the problems when we applying agricultural mechanization in our country, there are human resources that must be prepared, field conditions that must relevant, and also the costs. Related to the cost, I want to know in Malaysia, is the machines, oh, I think it is already answered. So some of the machine is owned by society, is it?
Yeah.
So yes, it is about individual, but some farmer who have capital, they also owned by themselves, right?
Yeah, yeah.
Okay. Okay, I think this is already been answered before. Okay, for this one, I think it's already answered before. So I would like to ask also about the implementation of IoT in agriculture. How about it? So we hear recently that many countries want to apply agriculture 4.0 and apply many IoT to agriculture in their country. So how about Malaysia?
Okay, thank you. So still, Malaysia is still one of the country that keep it up to date with the latest trend. So at the government policy, at the government level, because they are aware that IR 4.0 or sensors, easy to say, the use of IoT, the use of sensors may improve our productivity. So there is a call. There is a call by government. They have a special grant. They have a special allocation with a priority for any research, for any development project related to IR 4.0. In fact, I got one friend from who is hired by the government just to train people for IR 4.0. So these people, they represent government agencies. They go to any agencies. If let's say I want to have that training, I just have to prepare 20 people, and then that trainer will come. They will explain to us what is PLC, what is IoT, how to use Arduino, how to connect the sensors, what is the internet, and etc. So due to that government policy, most of the researcher at the university also try to be in line with that in order to secure research grant. So in fact, one of the company where we have MOU asked me to build remote control, sort of remote control rotary tiller, power tiller for their technology, for their company. So they said they can give the machine, they can fund the research, but what they want is after certain time, they need a remote control power tiller. So yeah, there is a trend, and then our country is also embrace that technology. So if you are expert in that field, it's easy to get research grant. Thank you.
Thank you very much. Okay, thank you very much. There is a question from Zoom chat from Mrs. Retno Damayanti. She is a doctoral degree student here. Greeting Prof. Nazmi. My name is Retno from Agriculture Engineering University of Brawijaya. I would like to ask about how big is the successfulness of using UAV in the fertilization monitoring or process, because the movement of wind will affect the process of spread of fertilization provided by the UAV. So this is a question about the implementation of UAV for fertilization.
Fertilization. So I mean, this is for paddy, right?
Yes, yes. Could be for paddy.
We use it for monitoring, but for paddy, where I involved with that project. There is a company set up by one agency. This company meant to replace or to be one of the contractor for chemical spraying, because currently we rely on labor. The worker need to work in the paddy field with difficulty with a knapsack sprayer. Then they have to spray the fertilizer, and then there is a risk they will transmit the disease from tree to tree, from plot to plot. So the application of UAV, we call it drone. Here we call it drone, which is controlled by GPS. In terms of efficiency, in terms of efficiency or efficacy, it was conducted. The study was conducted by my colleague. I think it was okay. But the problem with drone is the battery, is the power supply.
Battery.
because if you go to paddy field in a rural area, there is no power electricity supply. You need to rely on the battery. So when I was there, I saw that the contractor need to replace the battery pack every time they finish one plot. So they bring with them a generator, they bring with them the spare batteries, and then after finish one plot, they will replace the batteries. So they will be time consuming for the battery replacement, and yet the sustainability of this business model or the operation is yet to be seen because it was introduced last 2 years. If you can solve the battery problem, it is feasible. But if the battery problem remain unsolved, it will be a challenge for us. But the chemical spraying is perfect. It's good.
I see.
Okay, in the chemical spraying, it's okay because we replace labor, but the battery is issue. Thank you.
I see. Okay, thank you very much for the question and answer. And there is one participant who would like to ask directly. So I will allow Miss. I'm sorry. Oh, she canceled the. Okay. Okay. Please, Miss Salsabila, you can introduce yourself and you can ask the question directly.
Okay, thank you for this opportunity, sir. Let me introduce myself. My name is Salsabila Farhani Alfianti from Agricultural Engineering, University of Brawijaya. Greetings, Professor. Let me ask you a question. As you know, there's a lot of bachelor graduates of agricultural engineering, and yet in okay. As you know, there's a lot of bachelor graduates of agricultural engineering, and yet in this current situation, we're still lack of farmers that really understand its field, and because of those graduates refuse to work directly in field. I want to ask your opinion. I mean, what do you think about that? Because from what I heard in Indonesia, this is a big problem. They think that working as a farmer is not for bachelor degrees. So what do you think about that? Thank you.
Okay, thank you. Similar situation, similar issue in my country or everywhere in the world. We have to change the mindset actually. When you have a degree, means you have enough knowledge. You don't, of course, you don't have to be a laborer. At least you become a manager. You have to manage. Say, for example, in my place, the place that I work for, is a contractor. He doesn't have a farm, he doesn't have a paddy field, but he has a tractor. He owns a tractor, about 10 units of tractor. He becomes a contractor. Unfortunately, he doesn't have any academic qualification. So the way how he manage operation, the way how he even didn't record any data for fuel, for maintenance. So you see, this is a lacking in our society. So if you're graduate with agriculture engineers said to be, so of course, don't force them to be a laborer, but force them to be a contractor. Force them to be somebody that can utilize the knowledge. Of course, they can start learning, how to do spraying, how to harvest. But sooner or later, because they have easy access to the government loan, they have easy access, they have a better network. Anytime they like in UPM, they train to be entrepreneur. We tell them about access to government loan, available training. So when they go out, they go for the training. Sooner or later, they can set up their own company. They can work for, any consultants or any contractors, and then, motivate them. You go to the farm, not as a farmer, not as a laborer, but at least as a manager. So that will change the mindset, and so more people will go to the farm. That is my opinion. Thank you.
Thank you, sir.
Okay, thank you, Mr. Sabila, for the question, and Prof. Nazmi for the answer. We have also one more participant who would like to ask the question directly, please, Mr. Darmanto, you can introduce yourself and you can ask the question directly.
Yeah, thank you for this time. And I want to ask about the comparison between Malaysia and Indonesia. As I know, in Indonesia, not all the farmer using mechanization process to cultivate their field in Indonesia. The question is experienced by not only community of farmers, but also for the individual farmers. The question is the Malaysian has the same problem like this? And the second question is, what is the role of the government of Malaysia to spread the utilization of mechanization for their farmer, because in Indonesia, as I know, not all the community of farmers that get the help, for example, at like a grant from government to develop their cultivation process using mechanization. Yeah. What is the role government of Malaysia to spread the utilization of the mechanization in agricultural field?
I got the second question, but I didn't get the first question. Can you repeat the first question, please?
Yeah, okay. In Indonesia, as I know, not all the farmer are using mechanization process to cultivate their field. Yeah. Even farmer community, not individual community. Yeah. And the question is the Malaysian farmer has the same problem or not? Like this.
Okay, thank you. Based on my experience, my engagement with farmers, first we have to differentiate farmers. Either they are working on paddy, they are working on vegetables, or they are working on fruit, because different farmers have different access to machinery. For example, if farmers who involved with paddy, no issue, because they live around contractors. Okay, but we go for vegetables or we go to fruit, those who own orchard, for example, durian or vegetables. So these farmers, some of them, if individual farmers, they depends on the land size and depends on the capital they have, also depends on the education. Because I got one connection, one farmer, successful farmers. He got a diploma in mechanical, but he involved in lemongrass harvesting, lemongrass plantation. He hired workers, but because of his education level, he came to us. He came to UPM. He said he has a problem for harvesting. Can we build a machine for that? Right. So meaning to say that if the farmers have an awareness and then they have an access about the importance of machinery, then they have money, they will buy. Even if not the big one, they will go for small one. But if they don't have knowledge, they rely on traditional method, they're more willing to pay labor, then there is another issue. But at our level, at Department of Agriculture, or even university, or even polytechnics, we always spread the knowledge. I mean the information about the benefit of machinery. Second question is the role of government. Okay, this is good question, because in Malaysia, the government agency is available in every district. We call it LPP, Lembaga Pertubuhan Peladang, or we call it, I forgot the name in English, but this is agency, government agency, they have a branch in every district. They have machine, they have tractors, they have implement. And then if farmers want to use, just go to that center. They can get at a better price as compared to normal, outside contractors. But in some condition, you have to be a member for that society. Then in certain cases, we also have a Department of Agriculture. They also provide service for land preparation, even expert advice. So again, it just depends on the farmers. If they have awareness, they know that they can get an access, they will go. But in every district, there are government agencies. So no reason if you do not want to use machine, because machine is there, you just have to go to the office. That is in Malaysia. Thank you.
Okay, thank you. Thank you very much for information.
Okay, thank you very much for all of the questions from the participant and all the answer from Prof. Nazmi Nawi. You almost come to the end of the session, and we have already had our head of department here, so we would like to invite her to deliver the closing speech. So please, Dr. Lakovia Hawa, time is yours. Oh, I'm sorry, Prof. Nazmi, please, could you stop the screen share? Yes.
Okay,
Okay,
thank you very much, Dr. Dimas. Assalamualaikum warahmatullahi wabarakatuh. This occasion, first of all, let us thanks to Allah Almighty God who has given us blessing and mercies so we can gather today in healthy and good condition. And guest lecture is an annual event that held regularly to enhance the staff and also the students' competence in agricultural department. And from this event, we can get the scientific and also the practical knowledge from another country. And today we are from Agricultural Engineering Department, proudly present the guest lecture from Associate Professor Dr. Nazmi Nawi from Biological and Agricultural Engineering, University of Putra, Malaysia, with the theme of Agricultural Mechanization in Tropical Country, Case Study of Malaysia. I would like to say thank you very much to Dr. Nazmi for great knowledge and also information. And we will say thank you very much because of this guest lecture is a collaboration between our department, Agricultural Engineering, University of Putra, Malaysia, and also the CIMIO CRK. I also want to say thank you very much for all committee members who work hard to prepare and also to organize this online guest lecture event, and also to all of the participants in this guest lecture for your attention, participation, and great question also. So last but not least, I'm looking forward to see positive outcome from this guest lecture and hope all of you will gain the utmost benefit. Once again, thank you very much to Associate Professor Dr. Nazmi Nawi for great knowledge and information. And okay, thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay. We would like to inform Associate Professor Dr. Nazmi Nawi that we will invite you again for 3-in-1 program for next semester.
Okay. Inshallah.
We will see you again. So, well, we has come to the end of the event. Before I end the Zoom meeting, I would like to inform you that we will have the second session of the guest lecture in around September or October. We will have on the next session of international guest lecture, we will have discussion with Associate Professor Ferruccio Giametta from University of Molise, Italia, about agricultural mechanization in subtropical country. I think it is also important to share between different area, and especially for the case of olive oil plantation. If Malaysia and Indonesia have oil palm, Italy may be famous for olive oil, and actually olive oil is, we call it zaitun. I think you are familiar. If you are Muslim, zaitun is one of the important plant that is mentioned in Quran. So it will be interesting to have the next international guest lecture. So we will keep update about the event in our official social media platform in Instagram, Facebook, and also YouTube channel. And you please follow the official social media platform of Faculty of Agricultural Technology, University of Brawijaya, and we will keep you updated. Thank you very much for all the participants. We apologize for any shortcomings during each event. I hope to see you again next time. Thank you. Keep safe and healthy. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Nazmi.
Thank you. Thank you very much. Thank you again, Dr.
Mr. Dimas.
Ya, terima kasih Pak. Jumpa lagi Prof. Nazmi
Jumpa lagi.
nanti. Belum sempat pergi Malaysia saya.
Insya Allah, welcome.
Oke, host bisa end session. Terima kasih.
Sama-sama.